classmates. The topic of my science project is how does an electric generator work? Electricity is a huge part of our daily life. Imagine a world that you couldn't turn on a light, an air conditioner, a computer, or even use the phone. We need it in so many ways. Obviously, electricity is very important to us. Nowadays, it is very easy for us to get electricity at home, or we can buy batteries conveniently in supermarkets to power our toys. Very often, I can't help wondering how electricity is produced. Therefore, I want to do a science project on this topic. When I was researching on electricity generation, I came across information saying that a generator does not actually create electricity. It is a device that moves a magnet near a wire to force the movement of electrons to produce electric current. It is just like a water pump causing water to move without creating the water in it. I think it is very interesting. So I would like to use magnet to produce electric current. The aim of my investigation is to find out if magnet can be used to produce electric current. My hypothesis is moving a magnet near a wire can create electric current, and I think the faster I move the magnet near a wire, the greater the electric current is produced. The control variables are the size of number and the size of the magnets and the length of the wire. The independent variables is the movement of the magnets, and the dependent variables is the generation of the electric current. The materials that I used to make the generator are 2 pieces of large magnets, a piece of 200 feet copper wire, a small light bulb, a piece of cardboard strip, and a large nail. The procedure that I used to make the generator are first make a hollow-ended box with the cardboard. Then use a nail to poke a hole through the center of the box. Next, fix the magnets around the nail. Make sure the magnet and the nail can spin freely inside the box. Then connect all the ends of the wire onto the box on about 250 turns. Finally, you connect the ends of the copper wire and the light bulb wires. The results are when I spin the magnet, the bulb will light. Can you see?
Yes.
When the bulb lights, it shows that moving a magnet near a wire can create electric current. When I spin the magnet faster, the bulb will light brighter. When the bulb lights brighter, it shows that a greater electric current is produced. Now I'm going to tell you how electric current is produced. All metals contain a movable substance called electric charge. An atom of a metal contains positive protons and negative electrons. Metals are special because their electrons don't stay connected to the metal atoms. Instead, they fly around inside the metal. In 1831, Michael Faraday, who was a British physicist and chemist, discovered the close relationship between magnetism and electricity. The copper wire surrounding the magnet is full of electrons, but there is no electric current while the electrons are not moving. When we connect the copper wire and the light bulb wire, a closed circuit is formed. When we spin the magnet, it creates a pumping action which forces the electrons of the copper wire to move, producing an electric current which turns on the light bulb. This is how the generator in the power station generates electricity. However, we need so much electricity that we cannot do the spinning simply by hand. Nowadays, the spinning is still mainly done by turbine. A turbine can be driven by the steam producing from burning coal, oil, and natural gas. These are called non-renewable energy resources because they will be used up in one day. The burning of these resources also produces a lot of air pollutants. In fact, we can generate electricity in a greener way. We can make use of river water, strong wind, or heat from the ground to turn turbines directly or to produce steam. These are called renewable energy resources. They are inexhaustible and pollution-free. This is the end of my presentation. Thank you. Do you have any questions?
Any questions?
Max here.
Julie?
Max.
Max does it.
You said that when the magnet go closer to the electricity.
No, it's that when
No,
you
is
move.
that, I want to ask you. Your title said. Oh.
Why? Julie, what's the generator?
The generator is that it is I don't know it's generate
It is the generator.
it's to generate electricity.
Okay, thank you. So I can